Hello everyone. In today's experiment we're going to connect three types of DC machines. So we're going to connect the shunt DC motor, and we're going to connect the series DC motor and the compounded DC motor, and we're going to reverse each one of them. We're going to also see the differentially compounded DC motor, which is something that you should avoid, and how to avoid connecting a differentially compounded DC motor. In this experiment we will connect the shunt DC motor and the compounded DC motor and the series. So what we're going to do first, we're going to connect to the variable DC source. We're going to connect the shunt. So first we have connected the rotor of the motor, as you see. So we connect the rotor of the motor to the power source, and then we're gonna connect the shunt winding. In other words, we're gonna, since it's shunt, it has to be connected in parallel. So as you see here, so it has to be connected in parallel with the rotor of the motor. Okay, and then we're gonna turn it on and observe the direction of rotation. So as you see here, the rotation, as you see, is clockwise. Now what we're gonna do, turn it down, turn it off. Now when we switch the terminals, what is gonna happen? So when you switch the terminals like this, the positive with the negative, you will observe that the motor will continue rotating in the same direction. So it should continue rotating clockwise. Let's see. As you see here, the motor continues to rotate clockwise. So how do we reverse the motor? So let's turn it down, turn it off. So to reverse the motor, you have to reverse one of the two windings. You cannot reverse both. Okay? Let's reverse the rotor windings and leave the stator alone. Okay? So I have reversed the rotor windings, and now let's turn it on. As you see, now the motor runs in the reverse direction, counterclockwise. Okay, now lower this, turn it off. Now let's connect the series motor. So the same thing, what we're gonna do. So now we're gonna take off the shunt winding, and we're gonna use the series winding. So you connect from here. Okay. Then terminal 4 goes to terminal 1 because they are connected in series, as you see. And then finally from there to the negative terminal. Okay. So now we have connected the series DC motor. So let's turn it on and run it. And as you see, it runs. As you see here, it runs clockwise. Let's lower this, turn it off. Let's reverse these and see what happens. Now from class, you should remember that it will continue running clockwise. Why? Because reversing the terminals will not affect. As you see here, it will continue running clockwise. So let's decrease it here, turn it off. Now what should we do to reverse it? So as you see here, we have to reverse one of the two windings, either the stator or the rotor. Okay? So let's reverse the rotor and turn it on. And as you see here, it's running now counterclockwise. Finally, let's connect the compounded DC motor. So the compounded DC motor, you first have to connect the shunt winding and turn it on momentarily for a short period of time to make sure that it's running so that you can tell what direction is it running on. So we're gonna turn it on now. As you see here, it's running clockwise. Turn it on. Now we're gonna connect the series okay, and repeat the same thing. So if it runs clockwise, that means all we have to do that means we have connected them properly. So it's running clockwise. So now what we're gonna do, we're gonna all just put insert that so from here, and there we go. So now the motor is going to run. Now we have connected the compounded DC motor. Now let's see. Now let's turn it back off. Now let's see what happens if we connect it in a differential compounding. In other words, you connect the series such that it runs it counterclockwise, and the shunt runs it so that, in the clockwise direction. We will get the differential compounded DC motor, which is something you should avoid. So what I'm going to do now here, I'm going to purposely reverse the series winding. Okay. So now we have a differential compounded DC motor. Okay, so it's something that you should avoid. But I'm going to show you here how does it run. It's going to be unstable. As you see here, it's an unstable motor. Okay? It's basically, they are fighting, you know, this wants to run clockwise, this wants to run counterclockwise. Okay? Thank you.